Hello CTM students, and welcome to part 1 of the chapter 12 review. We're going to be doing these problems here. Just a second, my slate got turned off. There we go. We're going to be doing these problems. It's going to be on these pages right here. It's going to be numbers 3 and 5 through 22. Those are the ones that I had assigned for right now. So those are the ones we're going to see together here. So let's get right into it. I will go through each problem step by step, show you how it's done. Hopefully you've tried all of these already as best as you could, and then this is just here as a resource for you to help you with the ones you need help with. So number 3, bicycles. Of 40 people who purchased a bike at a bike shop, 8 purchased a mountain bike. Find the empirical probability that the next person who purchases a bike from the bike shop purchases a mountain bike. So empirical probability, remember, is based on things that have happened, things that we've done an experiment on, or things from a survey or something that actually did something, rather than theoretically what would the probability be, what would the chance be. And we're saying here 8 people out of 40 actually purchased this mountain, or actually purchased a mountain bike. So probability, mountain bike is going to be what you want over the total. Probability of anything happening is what you want over the total. That idea just keeps showing up over and over again. I think that's the easiest way to think of it. So what you want is somebody that picked a mountain bike, how many people picked mountain bikes, over the total, how many total people bought a bike in the first place. So there were 8 people that purchased a mountain bike over 40 total. So it's as simple as that. You just need to reduce this, divide by 8, you're going to get 1 over 5. And so based on the results, or based on the things that have already happened, we're expecting that the probability of the next person to come in the store, based on people that have already been there, if that person has the same sort of if that person has the same chance of picking a mountain bike, this is what their chance would be, 1 out of 5, based on what's already happened there. Let me move on. Let's move on to number 5 though. So television news. In a small town, 200 people were asked whether they watched ABC, CBS, NBC, or Fox News. The results are indicated below. Find the empirical probability that the next person selected at random from the town watches ABC News. So we've got ABC. We're wanting to put ABC. That's what we want on the top. So ABC News out of the total number of people that watched. This would be our probability, the empirical probability based on these 200 people. So 200 people total, 80 were watching ABC. So if we say 80 out of 200, that's what we're looking for. You could cross off the single 0. So you'd have 8 over 20. That's like dividing both parts by 10. This, you could divide this by 4 and this by 4 as well, and you would get 2 out of 5. So you could say this. You could also say 40% or 0.4, but if they don't ask you what particular way they want it written in, fractions are always okay. Alright, so that's good to go for number 5. This is number 5. This one back here was number 3. Some of these will have multiple numbers like this here, so number 6 we'll do here. Digits. In exercises 6 through 9, each of the digits, 0 through 9, is written on a piece of paper, and all the pieces of paper are placed into a hat. One number is selected at random. Find the probability that the number selected is even. So there's not just 9 digits, there's 10 digits. Don't forget about the 0, it doesn't want to be left out. So 10 digits total, and how many of those are even? So here is what we have, is what we want is even out of the total is going to be 10 digits. Do we consider 0 to be even? Is it divisible by 2? I guess I'm looking at the answers in the book right here, and it looks like they do want us to consider 0 as an even digit. I think you could argue both ways. Let me actually look that up a second and see what some people online have to say about that. Okay, so the quick answer to that, since 0 is divisible by 2, 0 divided by 2 is 0, you still get a whole number. They're saying that's even. So I hear them out there. I agree with that. So we're going to say 0 is an even digit. That means we have 5 even digits out of 10 total. That can be reduced to 1/2. And so our answer should should be 1/2. That's an ugly looking 5. That's a 5, I promise. That's a little better. There we go. Number 7. What we want over the total, odd or greater than 5. So I'm going to look at the list here and circle the ones that are odd or greater than 5. 1 is odd or greater than 5. 3 is odd. And then 5 is odd. And then 6 is greater than 5. And so is 7, 8, and 9. So it looks like those are my choices. Only 0, 2, and 4 are neither odd nor greater than 5. And so we have 7 choices out of 10 total. That cannot be reduced. So number 7, that's the answer, 7 out of 10. Number 8, which ones are greater than 2 but less than 5? So let me erase what I had here before, and we'll do the same sort of thing. Look at the list. Sometimes that's the best way to do it. Just look at the list, look at the sample space, and circle the ones that satisfy what you're looking for. So which ones are greater than 2 or less than 5? So it's not greater than or equal to, but it's actually strictly greater than. So greater than 2, 3 is greater than 2 and less than 5. So is 4. 5 and 2 are not greater than 2, and 5 is not less than 5. So this would just be 2 out of the 10, or 1/5 reduce. So always reduce your fractions if you can. And let's check out number 9. Hold on a second before I do that. So greater than 2, I was misreading this. See this word right here? Ooh, bad, Mr. Wagner. It's not, if it said and, then I would have done it right. So greater than 2 and less than 5. But I did not do this right. So I'm going to have to erase what I just did there. Woo! Sorry about that. That's why I check my answers. Getting lazy. Getting lazy in my old age here. Greater than 2 or less than 5. So anything that's greater than 2 will work. So 3 is greater than 2, 4, so is 5, 6, 7, 8, and 9. Or less than 2. So it doesn't have to be both being true at the same time. Less than 5 would be 4, 3, 2 is included, 1 is included, 0 is included. So this one's actually 10 out of 10, which equals 1. So there's a 100% chance of that happening. My fault about that one. Now, aha. Even and greater than 4. So this one has both things happening at the same time for number 9. So now that I got my understanding of the question right, hopefully I'll be able to get this one right. So even and greater than 4. Which ones are even and greater than 4? 0 is even, but it's not greater than 4. 2 is even, but not greater than 4. 4 is even, but not greater than 4. 6 is even and greater than 4. 8 is as well. So this one should be 2 out of 10, and that's why the answer in the book is 1/5. It can be reduced to 1/5. Okay, let's check out numbers 10 through 13. They're all using this table here. So in exercises 10 through 13, assume that 240 people are selected at random and are asked to name their favorite national park. The results are summarized in the following chart. If one person from those surveyed is selected at random, find the probability that the person chose. And then 10, Grand Canyon National Park. So what we want is Grand Canyon National Park out of the total people that responded. So there's 240 total people. Grand Canyon National Park would be 50. So you have 50 out of 240. Remember, you can cross off. If they have the same number of zeros, you can always get rid of those zeros. So this becomes 5 out of 24. I am a huge fan of the national parks. I've been to a lot of them and hope to see some more. So all of these ones I've had the privilege of being able to visit, all amazingly beautiful. Of these ones, I think I got to go with Yosemite of these ones. Glacier National Park is another favorite of mine. That one not on here. Shame on them for not including that one, but Grand Canyon is pretty spectacular too. They're all spectacular. Rocky Mountain, Great Smokies, great places to visit. If you don't visit the national parks, shame on you. Shameful. Yosemite National Park. So Yosemite out of the total is going to be, Yosemite's 40. So you have 40 out of the 240. Get rid of the zeros. 4 divided by 24 can be reduced to 1 out of 6. You can divide each part by 4, and so you should get 1 out of 6. Number 12, this one, either this or this. So it could be this or this, Rocky Mountain or Great Smoky. So that's this or this would be 35 plus 45 is what you would want. Over the total would be 240 still. So we have 80 out of 240, which is, get rid of the zeros, this would become, it's only if they have the same number of zeros. You can't get, if there was 2 here, you can't get rid of just 1 and then 2 down here. You got to get rid of the same number of zeros. 8 divided by 24 is the same as 1 over 3. And so that's good for that one. And then a park other than Grand Canyon National Park. I'll show you a couple different ways to do this one. So other than Grand Canyon, you could either add all these up and figure out what that is. So that's probably the most obvious way to do that, I think. So we could add all those up and see what we get. This would equal, this would be 75 plus that would be 120, 190, and so we should get 190 over 240. Get rid of the same number of zeros. That reduces to 19 over 24 then. So that's one way to do this. The other way to think of it is to think of, well, the chance of other than Grand Canyon National Park is the same as everybody minus the ones that like Grand Canyon. So this is another way to think of this. You could think of it as the total minus just the Grand Canyon part over the total. So that's the same thing. That's 190 over 240. So 2 different ways to think about this one. Right, let's move on to number 14. 14 states this. 14, Planters Peanuts is having a contest. They indicate that 1 in 10 jars will have a gold star under the cover. Jason Dwyer purchases 1 jar. Find the odds against and in favor of his jar having a star. So in class we talked about a way I think that's easier than what the book states in terms of figuring out odds against and odds in favor of. And so let's do this problem thinking of it that way. So if there's 1 in 10 jars, what we have in terms of in favor of and against, so the ways to succeed, think of it that way. So the number of ways to succeed is 1. The number of ways to fail and the total number of possibilities, we're saying there's 10 jars, 1 of those is a success. If 1 is a success, it would make sense that 9 are going to be failures. So failure or fail would be 9. And so odds against, remember, odds against is the number of ways, or it's this fraction, it's the number of ways you can succeed, goes on the bottom, it goes on the bottom. And then the number of ways you can fail, failure ways, goes on the top. That would be the odds against. So this is going to be 9 out of 1. Another way to write that is 9 to 1 like this. So usually you see odds against or odds in favor of like that. And then odds in favor of is just that flipped around. Success goes on the top. That's a good thing. That's in favor of on the top. That's what you want to happen if you're talking odds in favor of. What you wanted to happen with odds against is you wanted failure when you're talking about that. So odds in favor of becomes success is what you want, succeeding is what you want for odds in favor of, over failure is what you don't want. So this would become 1 over 9 or 1 to 9. So it's just this flip-flopped around. That's part B. That's it. All right, we're ready to move on to 15. 15, vegetable mix-up. Nicholas Delaney, a mischievous little boy, has removed labels on the 8 cans of vegetables in the cabinet. Ooh. Nicholas's father knows that there are 3 cans of corn, 3 cans of beans, and 2 cans of carrots. So let's see, that sounds pretty important to me. 3 corn, 3 beans, 2 carrots. If the father selects and opens a can, 1 can at random, find the odds against his selecting a can of corn. I'm still laughing that they put this in there. Oh, he is mischievous. He is devious. That young boy needs a timeout. Let's see what we have here. So odds against is selecting a can of corn. So success in this case would equal corn, which would be, there's 3 cans of corn. So failure in this case would be not corn, and there's 5 cans that aren't corn in the total number. It should always be the success plus the failure, and so the total is 8, just like it should be. So this one, what's the odds against corn? So odds against corn, the odds against, remember what you want goes on top, what you have as the, or with odds against, sorry, it's success, it's failure over success. I'll get this right one of these times. It's failure over success. So what you want becomes the failure in a sense versus the success ways on the bottom. So I put succeed before success, that's meaning the same thing. So failure, not corn, be 5. Success would be 3. So the odds against picking corn, there's 5 ways not to pick corn versus 3 ways to pick corn. So the odds against would be 5 to 3. And I believe that's all we have to do for this one. Yep. Number 16, horse racing. We got the odds against buttermilk winning the Triple Crown in horse racing are 82 to 3. Find the probability that buttermilk wins the Triple Crown. So in this case, if you have it listed like this, here we have odds against. So that means this is the ways to fail and this is the ways to succeed. So you've got failure in this one. I'll keep success at the top, sorry. Success is better, right? So success, put that at the top. Failure, we'll put that underneath it. Success ways, there's going to be 3 ways to succeed versus 82 ways to fail according to these odds, the odds against. That means the total with these together is going to be this plus this, 85. And so the probability becomes what we want to happen. We want to succeed over the total number of ways. So the probability of winning would be success. Success, there we go, over the total, which would be 3 out of 85. 3 would only be divisible by 3. If you add these digits, cool little trick here, 8 plus 5 is 13. 3 does not go into the sum of the digits. 3 does not go into 13. Therefore, 3 does not go into 85. So I checked that without a calculator even. So, but you could try 85 divided by 3, and you would find that it doesn't work. So 3 to 83. 3 to 85, excuse me. 3 over 85 would be the probability. Okay, jitterbug contest. The probability that Bob and Sue, Neno, will win the jitterbug contest, I think that's a kind of dance, is 0.7. Find the odds in favor of them winning. And so whenever we have these odds in favor or against problems, it's good to first figure out success, failure, and total. And when it's listed as a probability, as a decimal like this, we know total is always going to be 1. So this is the probability that they win. The probability of success, in other words, is 0.7. So the probability that they fail would be 0.3, because this plus this has to add up to the total. So let's see what we got here. The odds in favor of them winning. Let me put winning in there. Oops, I don't want to do that. That would be success over failure. So success is 0.7, failure is 0.3. With this one, I would say we should move the decimal. We don't want to have decimals and fractions together, so we can multiply both parts by 10, and then that would be the same thing as saying 7 over 3 or 7 to 3. So if you want to do it the way the book has these problems listed, you're welcome to. I think it's a lot more convoluted, a lot more difficult to think about. Think of it this way, and it's a lot easier to get to the answer in my opinion. But let's check out number 18. Any more odds against? This is now expectation problems. Okay, so a raffle ticket question. 1,000 raffle tickets are sold at $2 each. 3 prizes of $200 and 2 prizes of $100 will be awarded. Assume that the tickets are replaced after each selection. 3 parts here. Part A, find the expectation of a person who purchases a ticket. So what can they expect to happen kind of on average or in the long run? What would happen here? So with expectation problems, we have E standing for expectation. We're doing this sort of thing. Probability of one event that could happen times the amount that you would get from that happening, plus a second thing that could happen times the amount, probability times the amount. In this case, there's going to be 3 different things that could happen. You could either win the $200 prize, the $100 prize, or nothing. And so we're going to have 3 different things to be multiplying together and then adding together after that. So times A3. So I'm going to say this represents the $200 prize. This represents the $100 prize. And then this represents no prize. So you are paying $2 for each one of these tickets. So the probability first of getting the $200 prize, that's going to be, it looks like 3 prizes out of 1,000 raffle tickets. So 3 over 1,000 is the probability. The amount that you would win, yes, it would be 200, but you did have to pay $2 for that ticket in the first place. So your net amount would become $198. 200 minus the $2. Okay, for this one, you'd have probability there's going to be 2 prizes of $100. That's interesting to me. I'm surprised that there's less prizes of the lower amount, but that's how they said it would be. So 2 over 1,000, and then that times not 100, but times 98. Again, you had to pay $2 for each ticket, so you're netting $98. And then the probability of the third thing happening, there's 5 total prizes given out. That means of the 1,000 tickets purchased, there would be 995, 1,000 minus 5. So 995 that didn't win anything over 1,000. And yes, we're assuming that they're replaced after each ticket, so we're assuming that that is possible there, what's happening. So this isn't going to be 999 or 998. There's still 1,000 tickets to choose from, and 995 that didn't get it. So we have here, this is going to be times a negative $2. You don't have to include the dollar sign right now, but we are talking money, so I'm just deciding to include it here. So from here, it would be a good idea to get out a calculator. So let's do that here. So this, I'm going to have 3 divided by 1,000, and then take that times 198. So that would be 0.594. Yes, I was saying it right the first time. Let's clear that off. So 2 out of 1,000, that's the same thing as 1 over 500. This times 98, so 0.196. And then this is going to be a negative because you've got a positive times a negative. So this minus, and you have 995 times 1,000, times 1,000, sorry, divided by 1,000. Let's clear this off. That would be way off. 995 divided by 1,000 times 2, we've already know it's negative, so times 2 will be 1.99. So we're going to have this 1.99. If we put these 3 things together, let's see what we get there. So this, oops, sorry, page browser just came up. So 0.594 plus 0.196 minus 1.99. That should be, so we're expecting on average to lose $1.20. So negative 1.2, which is the same thing as minus $1.20. And I don't read that up. There we go. So this is our expectation. It's a raffle. With raffles generally, yes, they're getting money by doing the raffle. Somebody's getting lucky and winning the raffle, but they still are keeping some of the money for whatever they're raising the money for. So $1.20 on average will be lost, so minus $1.20. B, find the expectation of a person who purchases 3 tickets. We don't have to do this all over again. We can just take the expectation of purchasing 1 ticket and multiply that by 3. So 3 times negative 1.2, that would be negative 3.6, or that's the same thing in terms of money as negative $3.60. So a person that purchases 3 tickets on average would expect to lose $3.60. Yes, they could win, but more times than not they're going to lose. So on average, that's what the average comes out to be. And then find the fair price to pay for a ticket. So if we think back to lesson 12.4, fair price was the expected value plus the cost to play. So if that's what it is, the fair price is going to be, the expected value was negative 1.2, the cost to play was $2, so I fill those things in there and there, and so a fair price for the ticket should be 80 cents, 0.8, which is the same thing as saying that. Alright, so that is number 18. Let's move on now to number 19, expectation of a card. So a deck of cards. If Cameron selects a picture card from a deck of cards, Lindsay will give him $9. If Cameron does not select a picture card, he must give Lindsay $3. We're going to find Cameron's expectation, Lindsay's, and then 100 times how much can he expect to lose or gain. Part A, expectation, same thing as before. There's 2 things that could happen in this one instead of 3 though. You can either pick a picture card or not pick a picture card. So there's going to be this, I'm writing this out. You don't have to write it in general like this. You could go right ahead and fill in the probabilities if you know those right away. But I think this will help us understand it better as a whole. So this would be picture card is one thing that could happen, and no picture card. That's the second thing that could happen. So Cameron is trying to figure out, is Lindsay giving him a fair deal, or is what's going on here? So he knows he knows his probability. He's going to work this out and see if he wants to play this game, see if it's a fair game for him. So the probability of picking a picture card. Remember, there's in a deck of cards, for each suit, there's 13 cards. And so there's 13 cards to pick from. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay, 13. There's going to be a jack, a queen, and a king. These are the picture cards. So there's only 3 out of 13 picture cards. And the rest of these you'd have an ace, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm leaving one out here. 10. I didn't squeeze that in here. Let's see. This will be 10. That's a 10 right there. Okay. So there's, what am I doing? I don't know. Ace is a 1, so the ace is supposed to be that. Anyways, there's 10 cards here that aren't picture cards, and then there's 3 that are. So that is that. So the chance of picking a picture card would be 3 out of 13. Times the amount that he would get if he selected a picture card, that would be times 9. So times $9 or times 9. No picture card, not getting a picture card, there's going to be, of these, there's 10 out of 13 that are not picture cards. And so this would be 10 out of 13 times the amount that he would lose. That would be a negative amount. We should take this times -3. And if you wanted to put dollar signs in front of there, that would be fine too. But this becomes, now let's get out the calculator. That's not the easiest thing to do in our head here. So this would be 3 divided by 13 times 9. So you get this. Well, you know what? Let's keep this as a fraction for now. I think that might be a better way. So I get a more exact answer in the end. So I'll put these both over 1. This would be 27 over 13. And this would become minus, this would be 30 on the top over 13 here. So the expectation is that he's going to lose some money. It's going to be minus 3 out of 13, which is approximately, so 3 divided by 13 is that. So each time he plays, expectation is that he's going to lose about 23 cents. So this is 0.23, or this is a minus sign in front of there, minus 23 cents. So that's Cameron's expectation. Lindsay's expectation is, it should just be the opposite of that. So I'm thinking about this. Do I really need to work this all out again? No, because the only thing that's going to change for Lindsay is that this would be a negative and this would be a positive. And so it would be a negative 27 over 13 plus 30 over 13. It should make sense then that Cameron's and Lindsay's expectations should be flip-flopped. If Cameron's going to lose 23 cents on average, then Lindsay's going to gain 23 cents on average. So this, I don't feel like I need to do all that work again, so I won't. It's just the opposite of Cameron's expectation. And then choice C, if Cameron plays this game 100 times, how much can he expect to lose or gain? So all we need to do is take this number and times it, multiply it by 100. So 100 times the negative 0.23, that's just going to move this decimal 2 spots, so 1, 2. And so on average, Cameron, if you play this game, you are a sucker. Alright, so you got tricked, you got duped. You're going to lose $23 on average. Is it possible that he could gain money from playing this game? Yes, but the odds are more in Lindsay's favor for sure. So minus 23. If the book says minus 2308, because if you look at this decimal, you have, if you move this, if you round it less, you would get $23.08 rounded off there. So we could say, or approximately minus 2308. With, in a sense, yeah, what we have here. That's with less rounding. So this would have been rounded off here. So minus 2308 with less rounding. Okay, getting there, getting close. Number 20, expected attendance. These expectation problems, they take a little longer, but they're very, very useful, practical problems. Lots of actuaries would do this to determine if their business is going to gain or lose money. By doing something like this, you can figure out if something's a good deal or not, if you're getting a fair shake by doing expectation type probability problems. If the day is sunny, 1,000 people will attend the baseball game. If the day is cloudy, only 500 people will attend. If it rains, only 100 people will attend. The local meteorologist states the probability of a sunny day is 0.4, probability of a cloudy day is 0.5, and the rainy day is 0.1. So the number of people expected to attend, we would say it's this same sort of idea. There's 3 things that could happen again. So I'll just keep things in general at first. So it's probability of one thing times the amount, and then that probably a second thing times the amount, 2, and third thing times the amount. So this would be, I would say, sunny. This would be cloudy, and this will stand for the rainy part. And so what's the chance, what's the probability that it's going to be sunny? The meteorologist said 0.4. And then if it is sunny, there's supposed to be 1,000 people coming to the game. If it's cloudy, that chance was 0.5 according to the meteorologist, and then the amount would be 500. And if it's rainy, that chance was 0.1. There's 100 people expected to come if that happens. And so we can take a calculator. If 0.4 times 1,000, you just move the decimal 3 spots, so that'd be 400. 0.5 times 500, that'd be half of 500. That'd be 250. And then 0.1 times 100, 2 zeros, move the decimal 2 spots. You would expect that to be 10 then. Okay, so we have 400, 250 plus 10, that's going to be 650, 660. So it didn't need the calculator after all 660 people expected to attend. So include units or what you're talking about when possible. This is saying number of people, so I should say 660 people. Very close now. 2 more to go. Club officers Tina, Jake, Gina, and Carla form a club. They plan to select a president and a vice president. Construct a tree diagram showing all the possible outcomes. List the sample space and find the probability that Gina is selected and Jake as president and Jake is selected as vice president. Okay, 21. Part A. Tree diagrams showing all possible outcomes. President, vice president. Apparently, I think we're supposed to assume, I don't think the book says this, but let's assume equally likely outcomes or equally likely possibilities. Right, so if somebody's going to be president, they cannot also be vice president. I think we can make that as a true assumption as well. I'll go with a vertical tree diagram. No, I'll go with a horizontal one. So, just kidding. Okay, so this one, 4 choices at first for president. So we split it up that way. Tina, I'm going to call T, Jake, J, Gina, G, Carla, C. So we could have Tina, Jake, Gina, or Carla for president. So this is for president. And then this will be for vice president. From there, you're going to have 3 choices for vice president. You already picked one of the 4 people for president, so we only have 3 people left to choose from. So this would be Jake, Gina, Carla. This would be Tina, Gina, Carla. This would be Tina, Jake, Carla. And this would be Tina, Jake, and Gina. So the sample space, this is all possible outcomes here. Sample space, we could do that right here, part B. If you're saying this represents that, so the sample space would be TJ, TG, and TC. Tina, Jake, Tina, Gina, and Tina, Carla. Tina, Gina. Then we have Jake, Tina, Jake, Gina, Jake, Carla, Gina, Tina, excuse me, Gina, Jake, Gina, Carla, Carla, Tina, Carla, Jake, and Carla, Gina. So that would be your sample space all right there. And then part C, probability that Gina is selected as president, Gina is selected as vice president. That's going to be this one right here. So where's Gina first and then Jake second? That's right here. That's the only way that can happen. We're not saying Jake is president. This is saying Jake is president, Gina is vice president. So we need Gina president and Jake is vice president. There is 1 out of 12 ways that can happen. There's 1 way that can happen out of 12 possibilities. So that should be your final answer here. This is all we need there. And then the tree diagram shows it all there. And 22. 22 says we got a coin and a number. A coin is flipped, and then a number from 1 through 4 is selected at random from a bag. Part A, construct a tree diagram showing all the possible outcomes. A coin is flipped. We're assuming this is not some crazy coin that I've never seen before, but a coin will have 2 sides, heads and tails. So we'll have H and T, and then from there you can pick 1, 2, 3, or 4. So 1, 2, 3, 4. Same thing, if you pick tails, you still got 4 choices. 1, 2, 3, or 4. So that's the tree diagram. The sample space would be H1, heads in 1, heads in a 2, heads in a 3, heads in a 4. And then tails in 1, tails in 2, tails in 3, tails in 4. So that's our sample space. Nothing else we need to do there. Find the probability that a head is flipped and an odd number is selected. So if I look over here, head and odd would be this one and this one. So there's 2 out of 8 possibilities. So that would be 2 divided by 8, which is 1 over 4. And part D, a head is flipped or an odd number is selected. So this is a difference here. Here it said and, so both things had to happen, head and odd. Now we're saying head or odd. So these are all having heads, and then or odd would be this one has an odd and this one has an odd. These 2 have both things happening, but these ones, it can be either or. And so we have 6 out of 8, which is 3 out of 4. And so that becomes our final answer. That's our final answer there. And it looks like we are good to go. Alright, so hopefully you'll find that helpful. Your test, my students, will look very similar to this. Hopefully it will be one that's not too hard. I think a lot of pretty basic concepts here. This might be the hardest kind of stuff, the expectation stuff. So make sure you're good to go, you understand that sort of thing going on. And remember to figure out success, failure, and total possibilities first. Then these odds in, favor, and against of questions become much, much easier. I would not recommend doing it the way the book does it, but it's up to you if you want to. And then don't forget probability, which you just want over the total. It's as simple as that. Hopefully you will do very well on the test coming up soon. All right, I'll catch you guys later. Have a good day.